This is the solution video for section 6.3, problem number 4. All right, so the problem says solve each differential equation. All right, so we're given dx dy. So please don't lose sight of the fact that this is dx dy, not dy dx. All right, so when I'm separating the differentials, I'm going to multiply the dy to the right side, which means I need to retain the stuff with y on the right side. So 3 minus y is going to have to stay over here. But first thing you need to notice is that this is squared, right? So I'm going to write this as 2 plus x squared divided by 3 minus y squared. Now, if I multiplied by dy, now dy is on the right side. Dx is still on the left side. So now I need to bring the stuff with x to the left side. So I'm going to divide by the 2 plus x squared. So I have dx over the 2 plus x quantity squared equals dy over the 3 minus y quantity squared. All right, so that's the first step that most of the time people make a mistake on. All right, now I've separated the differential, so now I'm ready to integrate. All right, but I want to rewrite these in order to integrate. So I'm going to rewrite this as 2 plus x to the negative second dx, and then 3 minus y to the negative second dy. All right, so now if I'm going to integrate this, I'm going to have to use a u substitution, but a different u on either side. So on the left side, I'm going to use, I'll call it u sub 1, all right, and that's going to be 2 plus x, and du sub 1 is just, well, it's just 1, right? The derivative of 2 plus x is 1 dx. So that means that I have, on the left side, I have the integral of u to the negative second dx, right? So I'm going to need a 1 with the dx, which means I need a 1 on the outside, which is really nothing, right? And so that means I have the integral of u to the negative second du. All right. On the right side of the equation, I'm going to use a different u. So I'm going to use, we'll call it u sub 2. All right, so that's going to be 3 minus y. All right, so du sub 2, right, is going to be, well, the derivative of 3 minus y is negative 1 dy. All right, so what does that mean? Well, that means on the right side, I have the integral of u to the negative second dy. I needed a negative 1 with the dy, which means I need a negative 1 on the outside. So on the right side, I have negative 1 integral of u to the negative second du. Now remember, on the left side, we're using u sub 1. So we want to make sure we actually call it u sub 1. So u sub 1 to the negative second, du sub 1. On the right side, we want to make sure we use u sub 2, right? So that when we are at this step, there's two different u variables. We can't use the same u because then it's mathematically incorrect. Right, it's mathematically confusing because we have multiple versions. All right, so now we're going to integrate u to the u sub 1 to the negative second. So I'm going to add 1 to the power, so this becomes u sub 1 to the negative first over negative 1, right? And then, of course, plus c, but we only need to add in c in one spot. All right, now I have the negative 1 and integral of u to the negative second. That would be u sub 2 to the negative first over negative 1, and then, of course, my plus c. So now we've got the negative on the outside of both of those, right? And so we've got the negative 1, and then u sub 1 to the negative first. So that'd be 2 plus x to the negative first equals, now those negatives reduce, so I'm just left with u sub 2, 3 minus y to the negative first. And then, of course, the plus c. All right, so that is problem number 4.